Welcome one and all to the lesson on solving for oblique triangles given side-side angle measurements, including the ambiguous case within itself through the law of sines. So if you haven't checked out the other video on the introduction talking about the rules for solving those cases, then go ahead and check that out. So again, we are solving for case 2 of the oblique triangles where you're given two sides and one angle not between the two sides, SSA or ASS, which I won't say out loud. But again, you can solve more than one triangle in one problem. Again, here the law of sines reviewed, and both in its original form and alternative form. Again, a good strategy is to have the form where the unknown variable is in the numerator and you put everything else around that. So here are the rules again put all together where you can determine whether you have no triangles, one triangle, or two triangles based on the information given to you on the angle and its opposite side and the other side. So go ahead and check out the other video again if you haven't seen that about the rules themselves. But as I mentioned at the end of that video, you can use these steps right here to solve for the triangles, and naturally if you do everything correctly you can determine if you had no triangles to solve, only one triangle to solve, or if you have two triangles to solve. So step 1 is to find the other angle using the law of sines. Step 2 is once you have two angles, you can find the third angle using the angle sum formula. Third step is to find the last side using the law of sine. And step 4 is to check for the second triangle, if possible, by repeating the steps in 1, 2, and 3 by using the supplement to the angle you found in step 1. So here's our first example. Part 1 is to first establish how many possible solutions or triangles are there given this angle and side. So we have angle A is 62 degrees, side A is 10, side B is 12. So based on the given info, we have B sine A, where 12 sine 62 is equal to this 10.59537143. That's one number. Why do I care about that? Because if you know the rules, then you establish the fact that you compare the side A to the height of the triangle, which is B sine A. As long as the angle given to you is less than 90 degrees and the side A is shorter than side B, so 10 is less than 12, which therefore we care about these two important aspects. And if we do it correctly, then that means that we have no triangle. Therefore there's nothing to solve. But let's say you still have trouble applying the rules and you want to just go ahead and solve them and see if you can figure that out, which you can't. So what you would first do is you would follow step 1, and step 1 is to find the missing angle opposite from the side you're given using the complete pair of the side A and angle A. So sine B over 12 equals sine 62 over 10. So therefore I multiply 12 on both sides, get sine B by itself is equal to 1 point, that entire decimal number. But then remember that if we want to find the angle, you need to find the inverse sine of that decimal number. And if you do everything correctly, you will get an error message. And if you draw the triangle, this is what you would get. So because the side itself is too short, it can't even make a triangle, so therefore there's nothing to solve and you get an error message. So there you go. So that's what would happen if you actually applied the rules to solving that triangle. Let's try a separate example where we have angle 98. For angle A, side lowercase a is 39, side lowercase b is 22. Now, because this one has the angle bigger than 90 degrees, we don't actually care about B sine A. We don't care about the height. So all we have to do is just compare the side A with side B. So therefore, since A is greater than 90 and A is greater than lowercase a is greater than lowercase b, one triangle does exist. So we know that we do have to solve one triangle. Now, again, if you don't remember the rules and you just want to go ahead and memorize the rules themselves, or the steps to solving the problems, here you go. So first thing is we establish finding the opposite angle from the given side of 22 of B, because we already have a complete pair using angle A and side A. So here's our law of sines set up. We get sine B by itself, sine B, equals this decimal number, but you take the inverse of that sign with that decimal number, and if you do that correctly, you get 34 degrees if you round it up. So again, don't round any of your numbers in the middle of the problem until you get to the end of what you want. So therefore, we can round to 34 degrees. So that would be this particular angle right here. This is what 34 degrees would be. Sorry, B. Now I'm not going to finish solving the rest. I'm not going to finish the rest of the triangle, let's say. But let's go now to step 2, where we find the missing angle using the angle sum theorem. So we have 98 plus 34. 98 is from the first angle, 34 is from the second angle we just found, and now we can use this to find the last angle, which is 48 degrees, which would be this part right here. And now we apply step 3 to find the last side, which is lowercase c, and we set up our law of sines where the missing variable is on the top, so the side is on top, and the sine of the angle 48 is on the bottom. So notice how it's kind of like the fraction flip between comparing with step 1. And if you do this correctly, you end up with this c equaling 29 point all that. And again, you can round that to 29.3. I would say general rule of thumb is to the 10th place. Now, I won't go too much into detail with this part, but step 4 is to take the supplement to the first angle given to us, or that we found, which is 34 degrees, and you get 146. So that would be our new angle B if we had a second triangle. However, you cannot apply step 2 to this, so therefore the second triangle doesn't exist. So if you actually try to use the angle sum theorem with 146 and the given angle of 98, it wouldn't work. So therefore you can't do it. Here's our last example, and this example has 2 parts, part 1 and part 2, because guess what? If you actually apply the rules here, first of all, before we apply the rules, notice how the given variables given to us don't match with the rules given. So what you can do is replace them with the ones we do know. So C, capital C, and lowercase c are going to represent our A's because that's our complete pair, and then B is going to stay the same because that's the missing side. The other second side we're given, and thankfully it's still the same, side B. So based on the given info, our angle A is less than 90, and therefore we do care about the B sine C. So that is what B sine A would have been, but again we replace the capital A with a capital C. If you do this correctly, 31 times sine 20.5 is this. And because the angle is less than 90 degrees, and because the side C is bigger than B sine C, 2 triangles do exist. So again, the rules work here that tell us how many triangles we need to solve. But again, if you don't remember the rules, you can just go ahead and apply the steps to solving this, and you would naturally get to that conclusion anyways. The only thing you need to take note of before we get to the first step is some problems may only just ask for you how many different triangles are there given, the measurements. Well, in that case, solving it would take too long to figure out that you would have 2 triangles. So sometimes it's good to know the rules to be able to know how many triangles there are. So step 1 is find the missing angle opposite from the given side that we have. That is not our complete pair because we have capital C and lowercase c. So sine B over all this revolving around it. You apply the inverse sine function to that decimal number you find, and therefore you get B is equal to 64.8 degrees. Then you go ahead and use the angle sum theorem. We know what angle B is, we know what angle C is, so this time we don't know what angle A is. So therefore it's 94.7. And then the last step is to find the missing side. We know that we're missing side A, so therefore we're going to put it over sine 94.7 degrees because that's the opposite angle from it. And then you always want to use the complete pair, the one that was given to you from the original problem, so 20.5 and 12. So therefore you set up the fraction like that, and you get A is equal to 34 point all that, which if you round to the 10th place would be 34.2. Now, let's apply step 4, where we are going to learn how to solve for the second triangle. So all this information is still the same from earlier. with knowing how to find whether two triangles exist or not. So this is our step 4, where we're going to find the supplement to 64.8 from step 1. So that, in other words, was our angle B that we found. That was the first angle that we found given the problem. So what that means is you do B from the first triangle plus B from the second triangle equals 180. We know what the B from the first triangle is, 64.8, and therefore our new angle B, so B2 essentially, is 115.2 for the second triangle. Now, the rest of this information that we're going to find is primarily for our second triangle, so take note of that. So step 2.1, so we're doing step 2 again, but for the second triangle is you find the angle sum theorem, or you apply the angle sum theorem to find the missing angle. So this is going to be our angle A, and I should have put this earlier, where it's going to be our angle A for the second triangle, so 44.3. You apply the law of sines again to find the missing side, which is the lowercase a. Again, we use the new angle that we just found, use the complete pair from the original problem to therefore find our missing side, which is a side, lowercase a, or side angle for the second triangle. So therefore 23.93, or if you round it to the 10th place, 23.9. And that's how you find the solutions for the ambiguous case, where you have two triangles, or one triangle, or no triangle at all. So again, here are the rules again, which is good to know so that you can just immediately know how many triangles you have to find. And then if you need to solve it, then now you know how to solve it using those steps from earlier.